Record. Yay, he remembered for once. So, if you had this on your screen for a little while, come on, Google. Alrighty. Let's talk testing. So, just a couple of things for all of you to keep in mind. There is homework due Monday night, so don't forget about that. And what we're actually going to do on Monday is a in-class lab. Should be fun and exciting, and hopefully kind of a nice little segue into break for all of you. It will be testing related. It'll be interesting, I hope. Some of you may have done this kind of thing before. Some of you may not have, but we'll find out on Monday what that is. And I'll send out an announcement to everybody so that you're all, again, aware of what's going on. It'll be, I think I said it was on Blackboard, but no Twitch stream Monday. Kind of the key takeaway. But give you all some practical experience. I know it's been mostly lecture so far. So let's try to break things up, and then hopefully it'll be a nice little wind down into your break, and you can focus on all of your other projects that you've got going on. Since you all seem to be overloaded. Here's a nice little cute design choice there. Red and gray, perfect. All right, let's get back to testing. So what we're going to cover today is we're going to wrap up test-driven development. If we get to the very end, we'll do a little in-class type of thing. I doubt we will get to it, though. We're going to wrap up test-driven, and we're going to talk about some of the other forms of testing that are out there today. And once we're done with our November break, it'll be pretty much all verification and validation from here on out. Meaning testing, meaning model checking, all kinds of fun and exciting things to make sure that your systems are working appropriately. So let's start off with a slide here. We've talked about TDD on Wednesday, and we talked about all the pros, all the cons, we talked about what it is. I even showed you an example in Java, and it was certainly Java. So I'm curious what you remember. What are the benefits? Weed out bugs before development is in its final stages. Okay, that's fair. The interesting thing with testing in general is weeding out bugs. So if you had a standard testing cycle, that would actually be a perfect answer. Test-driven development, if you remember, we're writing our test cases along the way. So basically, you're going to write a test case, then you'll write some code, and your code will make that test case pass, right? So is that whole agile notion where it's a lot more flexible, and we're building up our test case repository as we go. Any other benefits? Quicker and easier to make tests. Yes. So if you consider testing to be a sequential operation, right? Dev, then test, you're going to have a lot of time spent making tests and going back and revising your code. If you build up your test library along the way, it's quicker, like you say right there, and easier, right? We've been looking at it from a unit testing perspective too, keep in mind. So these are little tiny bite-sized tests, testing the smallest things possible. Testing your functions, your classes, modules, if you start going up in a little bit of abstraction. Basically, that test library that you're building up will save you a lot of time in the long run. And keep in mind too, these tests can be reusable. So if you start, doing other projects that are similar, and maybe they rely on similar classes, maybe they rely on, similar modules, or you're importing from other places, you can reuse these tests, right? You can copy them over to your current project, maybe tweak them a little bit to fit what you're currently doing. But that can basically save you a lot of time in the long run. Now, there's a comment in my morning class which I quite liked. It basically, one thing you could consider too is that it might remove bias from your testing, right? So you are initially writing your test cases to basically follow your requirements, right? So you haven't written a single line of code yet, but you have written test cases that hopefully capture what you're supposed to be doing. So if you're writing code towards that test, which is already constructed around a requirement, you might not be writing crappy test cases, right? You are hopefully writing test cases that actually specify something. If you find a rare bug, you're supposed to fix it immediately, then pass all the time, or keep it low priority. That's a loaded question, I would say. Um, I would say any kind of a bug you should probably make an effort to fix, right? I mean, if you find something and you know it's a problem, it should probably be resolved when you've discovered it. But the reason I said it's loaded is that if it's going to take months of time to fix and you have to completely revamp everything, that would definitely be a consideration. Or you roll it in, maybe you abstract it out. You remember we talked about how we handle issues a while back? You offload it to somebody else, you fix it yourself, you bring in a contractor. Just kind of depends, I would suppose. But I think if you discover any bug, ethically, it's your responsibility to, at the very least, write it down and report it and make sure it's resolved at some point. Otherwise, it all starts kind of accumulating. All right, so good guesses so far. Excuse me. So let's talk about some of the different types of testing that are out there. We've been looking at unit testing mainly. Excuse me for a sec. All right, sorry about that. So we've been looking at, again, unit testing, little tiny bite-sized pieces. So this figure I grabbed off the internet. I probably should do it myself because there was a lot of spelling errors in here. You can see these little boxes I overlaid. Actually, there's a spelling error right here I forgot to fix last class. But basically, it lists out some of the different types of testing. Now, I'm going to talk about this from bottom up because we've talked about unit testing. I've kind of mentioned integration testing in passing. We'll talk about that a little bit today, but basically you're seeing if two components, merging them together, still passes all your tests. But we have, like, again, different levels, different types of testing. System testing, user acceptance testing, these are all in the functional realm, right? You remember you had functional requirements, you're gonna have functional test cases. We had non-functional requirements. Hey, we have non-functional test cases. You can see the functional, again, they're very rigorous. They're very quantitatively defined, basically, right? So unit testing does value in match, does expected out match, does intended behavior inside match, that kind of a thing. Non-functional here, we look at concepts like usability, performance, security, compatibility, concepts of that nature that are a little bit harder to nail down. So we have these kind of different types of testing. And the next level here, we have different categories of testing. So is it white box? Is it black box? Remember we introduced those terms 4 or 5 classes ago. Remember we talked about white box and black box. And the same notion applies here. That's kind of why I said don't forget this term. White box, you know what's happening inside. So when you're testing something, let's say that I'm going to test a program. If I'm white box testing it, I give it some inputs. I'm expecting to see some kind of an output, but I know exactly what's happening inside. I'm actually testing like the internal algorithms or the internal mechanisms, right? It's not some object that I'm testing. Contrast that with black box testing. You have no idea what's happening inside and you don't care, right? You could be trying to just sort a list of numbers or a list of objects, and whatever algorithm is inside this class, you could care less. You just want to see unsorted list going in, sorted list coming out. So that's black box. White box, you know what's inside. Black box, you do not know what's inside. Gray box, you kind of have a mix of the two. So you have some knowledge of what's going on in the internals of this system under test, basically. You might be testing the inputs and outputs. You might also be testing the internal algorithms. It just kind of depends on what your level of abstraction and perspective is for testing. What do you need to know to perform the test? But the interesting thing to talk about here is, do we run these tests manually? Do we run them automatically? I think last time somebody brought up the question, can you automate all these tests, right? Because I was writing little unit tests in Java, and it was very piecemeal, test this, test this, test this. But when I clicked run, it ran every single test automatically, right? So I got a bunch of like green checkboxes or red, green, yellow checkboxes effectively, right? So these test executions are being automated. Now, you have to write them manually because you have to know what to test generally, but you could also perform test cases manually, right? You might have a checklist of like, let's say 100 tests that have to be run. Okay, test case one. I need this set of inputs. I need to configure the system in this particular way. I run this set of steps to initialize everything and get it up and running, and then I look and see what the behavior is. Does it match what I have written down? Yes, it passes. No, it fails. Report that failure to the dev team, basically. When I was working in industry, most of my testing that I did on real world embedded systems was all manual. Like I had to check, are these register values correct in a particular, a software register? Or does the system boot up within 30 milliseconds? Otherwise, we basically violate our requirements with our customer. Now, you could automate some of that, but it would be very expensive for that kind of a project. Um, but kind of the key thing to keep in mind is that all these test cases, they can be automatically run, they can be manually run. And one other thing too that's going to be kind of interesting is automatically generating test cases, right? Because think of all the effort you will have to go through to make a spec full of test cases, right? Test case 1 through 500. It takes you, the developer, the tester, probably weeks to figure all this out. Wouldn't it be cool if we had something that just automatically figured that out? Now, yes, it would be cool, but it's not always perfect, and it's not always exactly what you want. So there's a lot of like exploratory automated test tools that are out there. I know there are some in like Eclipse and IntelliJ where it looks at like class diagrams, looks at your various UML models, or even the bytecode of your Java programs and spits out test cases. There is one that I came across at a conference recently for Python. So it's called Penguin, Pynguin, and it automatically looks at your Python code and generates tests based on what you have there. Now, I don't have it fully working, so I'm not going to show you it running. And it takes probably like on my computer 10 to 15 minutes, maybe 5, depending on which algorithm I pick. It takes a little while to generate them, so I just want to kind of show you what it is. Do I have a execute? Maybe. There we go. So if I wanted to generate some test cases for a particular Python script, I could call this Penguin application, tell it this is the module I'm looking at, and this is just like a class of a person. Yeah, sorry about that. Were you looking in Discord or? Should have popped up. Yeah, okay. Well, at least it's recorded. That's weird. The morning class mentioned that they were having some lag issues too, so I wonder if something network's going on. But kind of the key here is that I would just call this application, it would generate a bunch of test cases for me. So here it's using randoop, which is like a randomized tester. It's more generally for Java, and I love the fact that it's randoopy for Python. That makes the 5-year-old in me chuckle. But if I ran this and I let it sit and run, I would get something kind of looks like this, where I've got a bunch of automatically generated test cases. Hey, let's instantiate some variables, let's instantiate some classes, and let's see what happens, kind of a thing. Again, I don't have it perfectly running, so I'm not going to show you it basically doing nothing right now. But it's kind of a cool idea to take and offload some of that development time. And I mean, if you get like function stubs or basic instantiations, that still saves you time. Might not be perfect, you don't have all of your branches being covered, but it's still kind of neat. So there is a lot to do with testing, and actually one other thing I wanted to show you too here. So there's this software testing wiki page. The only reason I'm showing you this is there are just so many types of testing, right? So we have different levels, basically talk about some of these, but we can do making sure that everything works when you install it. Acceptance testing, continuous testing, where it just always is running in the background. Performance testing, A/B testing we're going to talk about today. Basically, there is a lot more to testing than you would expect, and it's a very significant piece of the development puzzle. And it's one that you might not always come on, this way, please. Over here, thank you. It's one of those things you might not consider being a lot of time and effort, and you know why we even talk so long about this. You're just validating output, right? But there's just a ton that goes into this, and basically don't skimp on testing if you can avoid it. So you have different levels of testing, right? So again, we've all been doing unit testing in these demos and in class so far. This is done by the developer. That is you writing your code, writing your little unit test, checking your functions, checking your classes. Again, the smallest little atomic pieces of your code. You are intimately familiar with it. You know exactly what the method signatures are, right? It's the return type, function name, parameters, method signature, test inputs, test outputs. That's good. Again, old stuff for you by now. We also have integration testing. So this is where, again, you're bringing together two different modules, say two or more. They work perfectly by themselves, right? They're passing all their unit tests. They probably pass their basic functional tests for your requirements, kind of going beyond the basics there. But do they still work when you put them together? And the reason why this could be a problem, maybe they're talking on the same network. Maybe they're on like the same communication bus. Do the packets that module A send out collide with module B and cause really weird behaviors? Or take this out of the embedded domain. Module A is a Electron program, so it's got basically Chrome running on the back end. Module B is your Java app, your Python application, whatever it is. And because it's Electron, it just eats all of your RAM. Insert funny Chrome RAM joke there. And then your specific program just dies because it has no resources. So that'd be a module interaction there. Basically, integration testing checks that. But you see here, the developer and the tester could participate in that. Again, you probably have good knowledge of how to check your program. Can you check your program with the rest of the system, basically, or with other components? And you bring in an external tester, to kind of provide a non-biased view of testing the system, or maybe they know how to incorporate these other pieces into your module. So the next level of testing is system testing. So this is your system as a whole. Basically take all of your little modules, your widgets, components, whatever they are, put them all together in one big happy application, and then test it as a whole. Check that all of your requirements are being satisfied. Check that everything that you're saying this application should be doing is actually happening. And when I say what you say it should be doing, that's all written down very specifically in your requirements docs, right? All of your UML models, all of your software artifacts, these are specifying behaviors. System testing will tell you, is it doing this or not, as a whole package. And at this level, you don't see the developer, right? They are out of the picture at this point, generally. You're going to have some, again, non-biased person or group, more than likely, checking the system as a whole. Then the last level here is user acceptance. So this is one thing that we haven't really talked about, but we actually do have clients and customers, and whatever we create, they have to be happy with. Well, what does being happy with something mean? They have their own set of internal requirements that they would probably publish to their, contractors or whatever your role is. And does it meet all of our requirements? So the clients have to be happy, the customer has to be happy. Whoever is purchasing or using your application has to be happy with what you have put out. So to kind of contextualize all this, let's say that this is term project testing. Unit testing would be you all working individually on your projects, testing your modules, your classes, whatever you have. Then you come together at your weekly meeting. Hey, I implemented this tile map. I implemented this dialogue system. I implemented this animation. Let's bring them together into a Unity project. Does it all kind of work together when we add in these pieces? Okay, if yes, then good. Item 3 here, system testing. You get to towards the end of the semester and everything's pretty much wrapped up, right? You have all of your modules are in place. You have one big happy Unity project or whatever project you've got going on. All the pieces are there, they're all integrated. Does your system as a whole express the behaviors you want it to? Right? Is it a playable game? Is it a functioning magic mirror? Is it a functioning calculator or calendar app? Whatever it's going to be, does it do what you're telling me it does? We don't have tester groups, so you're still testing it yourself, basically. But then you get to item 4, that's final exam day. That's when you deliver your projects to me, and I check and see does it meet all my expectations. I am ticking off my acceptance tests. This would be actually kind of an interesting way to restructure this class in the future, now that I think about it. But does the separation kind of make sense? Again, having a separate tester group removes all that bias that you as the developer have. And we've talked about this before. When you're writing code or modules or anything like that, it's very easy to get kind of hyper-focused on what you're doing, and you miss obvious problems or obvious bugs. Testers will pick up on that. End users definitely will pick up on that because they will see all of your flaws. They're not going to gloss over it. If your client has high expectations, get a new client. Well, unfortunately, you can't trade me for anybody else this late in the semester, so. My expectations are minimum viable product, so I guess that's middling expectations. Thing I should mention too, though. So the kind of the takeaway from all of this testing is that I'm going to be expecting all of you to do some kind of basic unit testing on your term projects. So one of the next things that you'll be doing is basically coming up with some unit tests and demonstrating them being run. So one of the questions you may have is, well, we're doing X project, we don't have JUnit. Or I'm doing Y project, we don't have Python's unit test framework. You can still do a unit test without a testing framework. Here, let's pick on the Magic Mirror crowd here because I know you're kind of the most different from everybody else, I think. One of your base tasks is Magic Mirror software runs with a bunch of modules, right? So here's the disc golf results. Here's the current temperature. Here is your "Hey there, beautiful" quote that pops up. Your unit test could be, does widget appear on home screen in top right corner? Yes or no? Yes, passing. No, failing. Simple. Right? So it doesn't have to be a well-constructed like function call. It can literally be something minute that you're checking manually or automatically. And the reason why I kind of threw that out there is when I said that this morning, at least, they're kind of my guinea pigs for the news that I'm dropping on you all. Some people got freaked out. Don't worry about this. It's not going to stress you out in the least. All right, so it should be a byline for this class. It should not stress you out. And if it does, please let me know and we can work on that. But it's basically just a little thing that you're going to have to do. I just want to see that you understand the concept of testing, kind of. Alrighty, so let's talk about some of the different types of testing that we have now. So we have talked about unit testing at length. I even showed you a Java example. Made my skin crawl, but I did it. And if I can do it, then you can too. No, you all have to use Java for your other classes anyway. But unit testing, just to kind of contextualize it and define it, look at the inputs, look at the outputs, look at the internal behavior. Does this tiny piece of a project do what you think it does? If yes, you're happy. If no, you have to fix this tiny piece. And the reason we do unit testing is to catch problems early on. If you skip unit testing, which a lot of places will do, you might miss out on some very, very obvious problems until later on in the pipeline. And believe me, if a problem starts very small and it gets ignored or made a low priority, to go back to one of the earlier comments, it will kind of balloon in complexity because a problem will generally impact other systems. And if it's a little tiny problem here, it's going to kind of spread throughout and become a bigger and bigger problem. The kind of funny thing with unit testing is I never had to do unit testing formally when I was working. Um, it just wasn't in our structure. But I could definitely have seen the benefit of having a formal process. That's not to say we didn't do it like internally. We just never had a formal unit testing like repository that we had to deal with. So it's definitely something that I would give advice that you should be doing. And if you look on a lot of GitHub open source projects, you will generally see a test directory with some unit tests in there. So a lot of people do actually perform unit tests out there. But I like this little infographic too. So the more pressure you feel, the less tests you write, meaning that you're stressed out, you don't spend time testing. But because you don't test, your code becomes less stable. Because your code becomes less stable, you're less productive, leading to more pressure, leading to even less tests. And you have this horrible downward spiral until project failure. How do you break out of this? Write more tests. Give yourself a pat on the back that everything's passing. But let's talk about integration testing. Now, this is one, again, where you're bringing modules together. And this could be done in a couple of different ways. So you are either testing the interaction between the two. Like for instance, if you have some kind of an interface that binds two modules together, you could be checking that interface to make sure, hey, these function calls line up appropriately. We are getting the appropriate data from module A to module B here. Or we don't have any data type mismatches. Anything weird that could happen. Let's use a real world example. Module A is being developed by the US, Module B is being developed by the European Union. And if we don't do this nice little integration testing, we realize, hey, I'm using Imperial, you're using metric, and then our rover crashes into the surface of Mars. Like that never happened. So integration testing catches that kind of thing. And I clicked, can I do, yes, okay. So integration testing, bringing pieces together. That doesn't necessarily just have to mean testing the interaction between the two. It could be integrating all your pieces into like a release candidate type of thing, where I've written my module, you've written your module, a third person's written their module. Let's compile it together into one application. Does bringing all these pieces together still make our requirements pass? Are they all satisfied? Or, again, by bringing in person C's module, does that break everything? Because maybe they're calling a function that we don't know about, or they're using modules or libraries that we don't have. So basically, again, you're just bringing pieces together, making sure they all work. And this would be a step in the testing process. For instance, just to give you a real world example, you are the developer, you write your unit tests locally, you're happy. Your team is all writing their individual components. Okay, it's time to generate a release candidate, meaning that we are making a build to basically iterate our software engineering process, right? We're trying to hit a milestone of some kind. Well, at that point, we have a particular person, not necessarily a developer. They're in charge of integrating everybody's modules together. So they're going to check out from GitHub your module, check out somebody else's module, check out somebody else's module. So I should say clone, not check out. And make them into one cohesive project. Maybe that means writing an interface to call all of these separate submodules. Then the integration test at that point, does everything function correctly? If not, go back and fix it. So integration testing can be a tricky thing, but it doesn't just have to be like API checks. It could be builds or something of that nature. All right, so the next one to talk about then is regression testing. This is something which you will be doing forever probably, but basically you're rerunning old tests is what regression effectively means. And why you would do that is that let's say that you have your project, maybe you've already gone through integration testing. It just kind of depends on your business setup, I suppose, what your software lifecycle you're following is. But let's say you're at a point where you have a stable build. Okay, so version 0.9 is our current version. Well, you perform a bunch of, I don't know, usability studies, you perform a bunch of various studies that tell you, hey, there is an issue with their current build. We need to fix module A, B, and C. And maybe the users don't like your interface, maybe there's a performance bug, maybe you just want to add on something new or remove something. Well, that means everything has changed. Your prior test cases are no longer valid. You have a different build. So what regression testing does is it sees there's a modification that has happened. It does not matter what type it is. Something has changed. We have to go back and re-execute all of our old test cases. Now the question is going to be, which ones do you execute? There's going to be another process of, do all of these test cases still apply? Right? If you add or remove features, you're going to need to add or remove test cases to reflect that, right? Because maybe checking that this returns a XML-ified string, like from our example last time. Maybe the removal was we're not doing XML anymore. We're doing JSON now. So any test case relating to XML is going to fail because there's no XML functions. But you need to either edit them or refine them to be JSON specific now. And that's just kind of one example, right? Maybe you just make some performance tweaks and your test cases all apply now, but maybe you need to add more. You need to finesse them, refine them a bit. It basically, which test cases are you going to execute? And you also have to kind of consider that maybe running this test suite is a days-long process. So if you have any kind of knowledge that maybe test cases 1 through 10 don't need to be run because they are not impacted at all, then you could prioritize them to be the last thing that you do. So again, kind of keep in mind, testing is not quick play and then you're done 5 seconds later. Sometimes it's a hours or days long process of running test cases. And if you're continually doing regression testing, that's padding out your project schedule, right? So just kind of one of those things to keep in mind. Alrighty. So we've got a couple moving pieces here. We have changes to our build. We have changes to our test specs, which means changes to our test cases that are in there. We also have this notion of maybe changing our test suites, which I've kind of alluded to. Those are basically just collections of test cases that you would run for one reason or another. What are some problems that you could see here? So let's say that we have to constantly run regression testing. What are some of the problems that can happen with that? And I should say this is a necessary thing. It's not something you can really skip. But what are some of the issues that we have to deal with and maybe try to minimize? Um, yeah, so yes and no. I guess I'd be interested if you have an answer for both. Sorry. If you have an answer for both of those, I would say they're both valid. Basically, I'm trying to get you to think of this procedure of regression testing as a manager. What are the issues that you foresee and how can you deal with them? Because I mean, you could have issues with both, right? So regression testing implies something and results imply another thing. Let's start with regression testing by itself. I guess I should also say issues, it's not a problem or that something's wrong. It's just something you have to deal with. Or is that too vague, maybe? All right, so maybe let me point you towards where I'm going with this. Running test cases can take time. If you add on new modules with side effects of needing additions to objects, you might have to add new unit tests. Yeah. So we've got a couple moving pieces here, right? We have to add new tests, we have to remove tests, we may have to edit tests. Basically, you have to go through this whole procedure again. Checking your test spec, which means looking at all of your previously defined test cases, checking the requirements they're tied to, checking to see if requirements had to change or not, prioritizing test cases, so maybe the ones that are most impacted by this change get prioritized to the front, and you can make sure that those all pass, and then maybe run the other ones kind of in parallel to normal development. And testing does take time, especially if you're doing it manually, right? If you have a testing group that's sitting down in front of your devices and doing things by hand, this could take days to weeks to months. So knowing what to execute when is important. But I like your point about the results too, because a failure in a regression test means that we've broken something, right? So then we even need to go further back and try to really figure out what went wrong. And there are lots of processes for dealing with failures. Like there's lovely fishbone diagrams, which I'm not going to make you do. Be happy about that. But how do you zero in on what the problem is, basically? Testing that demonstrates a failure is actually a very good thing. That's why it is there. Like you don't want your tests to always pass. You want them to show you the problems because that helps you construct a well-built application. Kind of the basically the thing that I'm trying to get you to think about here is testing will take time, and make sure that you are prioritizing your tests appropriately and you're taking the appropriate time to basically make sure they all reflect reality, I guess. Should also say, before we move on, regression testing also gets performed if you change your requirements. So if your customer comes to you with, hey, we also need this, this, and this, well, golly, you also need a bunch of new test cases for that, meaning that does that also impact the rest of your system because things have changed? All right, next type of testing that we're going to talk about here, A/B testing. You probably all have experienced this because you are users of applications and websites out there. Google is notorious for doing this. Tends to be more of a web or like a mobile application type of testing, but basically you have group A, you have group B, and they get two different instances of this application. Generally, it's with like front end or GUI testing. Who likes this interface best? Do you like it with this color scheme? Do you like it with this color scheme? What about this layout? What about this layout? That kind of a thing. It doesn't have to be GUI. It could be algorithms under the hood. Maybe one's a little bit more performant for older devices, but it's a little bit uglier. Group B gets the slower one, but it's, angular and it's beautiful, but it's not as optimized, for lack of a better word, I suppose. So you do this when you want to experiment with different versions, right? Which version is best? Okay, let's go with this one from here on out. Anytime you click send feedback to developer, basically, there's a good chance you're participating in A/B testing, right? Because they're scanning all this data coming in. Based on the build that you have, they will identify these are all the problems with this build. Let's use this build instead now. Lovely example. Facebook did this a while back. I don't know if it was intentionally A/B testing or if I clicked something by accident. I really try to avoid Facebook these days other than for work. But one day my Facebook was all weird colors, rounded edges, bubbles everywhere, exceedingly ugly to me. Everybody else's nice, what is it, material type, square, blocky type stuff. So you present different interfaces to different people and see what the feedback is, for instance. Let's see. They can do this on the App Store too. Yeah, I mean, you can push different versions to different people. If you look in Steam, I think you can opt for varying versions as well of applications if they provide that. Yeah, anytime that you want to deploy an application to somebody, you can always publish multiple versions of it. I should say on the App Store, I'm not necessarily sure how it's handled from their backend, but I know it's feasible. Very common for at least eliciting user feedback, if not other applications. All right, next one, stress testing. This is a fun one. And this is one where you're probably going to see it mostly in, like, again, websites or some kind of mobile application. Basically, any kind of thing where you are going to be accepting connections. And you would do a stress test to see how well it performs under pressure. Meaning, does a spike in traffic break your system or not? Does a spike in data coming in break everything? Reddit's a lovely example. Anytime a major news story happens, or a holiday happens, or people are just very bored, you see those servers go down. They're being overloaded. You would do a stress test to see how many users you can handle until things shut down. Then you would like implement a load balancing strategy that would handle that at that point. But examples would be simulating like a denial of service attack or distributed denial of service attack, depending on your testing framework that you've got. Check to see if there's a load spike. Maybe you have an application that's serving, like an application type of server thing where you're serving Office 365 to all of your workers, and everybody shuts down and goes remote, and then all of a sudden we are all accessing the server at the same time from home. Is it getting overloaded or not? Probably a similar example since it's just a web app nowadays. Or consider, I don't know, a gesture-based application or a phone application. I start tapping it, maybe throwing on a bunch of gestures at the same time, and the system is struggling to keep up with all these inputs. Maybe it queues them all, and then it just gets bogged down with too much data, too much input. So you're basically checking to see what happens under pressure. This is more in the non-functional realm, more in the system level, close to release realm, I would say. But they're definitely important, especially if you're handling multiple connections. So how do you do that? One of the more popular tools out there, especially if you're running a web server or some kind of a networked application, is JMeter out of Apache. Nice little open source type of thing where basically you can just blast a target with requests. I'm not sure how familiar you are with web servers, but every time you make a connection, that creates a new process or a new thread. You create too many connections, server shuts down or goes into a save myself type of mode. That's basically what we're doing here. There's a open source Google one too called Bombardier, written in Go. I've used it before. It's pretty lightweight and interesting, but there's a ton of other tools out there as well. Okay, so we've talked about testing. Let's talk about why people avoid them. So this is from these two people, Dave Thomas and Andy Hunt, and I think my face is covering this now. They wrote a book called The Pragmatic Programmer. Interesting if you're into the whole software engineering type of thing. I'm going to pop all these up on the screen because I want to get to what a test case looks like as well. But these are all reasons or excuses why you don't write unit tests. It takes too much time. They're useless. They break the development flow. It's unnecessary. It's complicated. So this is actual comments from developers. Now, item 2 here in particular is quite interesting to me. The argument is that unit tests are useless because you're already doing integration testing. You're already doing functional testing. Why do we care about unit tests? Basically, it's the idea that we are doing too much testing as it is. We should, not waste our time with it. And that's actually an interesting thought because, hey, maybe our integration tests or our system tests would catch unit test problems. But the counter argument is you could catch these problems a lot sooner, and then you wouldn't have that problem at the later on stage, right? Plus, you're also building up your test repertoire with this test-driven development idea. I see these as excuses, not necessarily as reasons, personally. Project managers tend to have a different view because testing takes time. These last two here as well are interesting to me because I have legacy code, I have code that can't be unit tested. So again, I'll pick on the Smart Mirror crew here. You're not necessarily writing code unless you're writing your own module, right? Which would be probably Node, I think. Maybe you're repackaging some of these modules and just moving configurations around or updating API keys or something like that. Again, you can still unit test it. It's just going to be represented differently. This legacy code one, though, is kind of interesting because you get a lot of legacy applications when you go work in real life, right? Maybe, hell, you're bringing in a COBOL or a Fortran application because it has always worked. Why get rid of it? Well, what you do as the developer, you wrap it in a nice little Java wrapper or a Python or a C++ wrapper where you don't touch that code, you just feed it the right data. Well, then how do you unit test this thing? That's a very good question. You're basically going to have to test the interface and make sure that it works, or figure out how to get into this old legacy code and do that. The counter argument, why you would do it. Remember we talked about Therac 25 on day one of class? Effectively, what they were doing was bringing in legacy code, copy pasting it. It worked before, it works now. Passed its test then. Why should that change now? The situation around that system changed, meaning that latent bugs started appearing. So it's always good to go back and test other pieces that you're bringing in. All right, what I am going to do, so managing tests, should probably talk about this. When you're writing your unit tests or any tests, keep them separated from your code in a directory called tests. That way you're not linking your test code and your production code in the same place. Basically keep them separated enough that you know what is testing and what is real code, basically. And when you're organizing your test code, and this is going to rely on whatever framework you pick to do your testing, make sure you can run them all individually. You can run them for each module, each class, each file, for the system as a whole, or not run them at all. Basically, you don't want to get to the point where you release your product and every time somebody clicks run, it runs your entire unit testing suite and maybe crashes on the user's end, or to save you time every single time you start debugging your program. Basically, be able to pick and choose what you want to run. It's kind of the takeaway. All right, last for today, let's talk about what a test case is, because I've been mentioning them, but any test case needs, at minimum, these fields. So we need an ID. We need to know which test case we're referencing. We need to know the scenario and how to execute the test. So basically, what are the steps to run this test? It's not always just like one thing. You need to know what the input data is. So what is seeding this test case, right? So system has to be on. You need to feed this application a string, so on and so forth. Then, what is the expected output? If I give a program this input data, what is the output going to be? I should have a very well-constructed idea of what that would be. And then record what you actually see. If you have expected output and you have actual output, if they match, test passes. If they don't match, test probably fails, and then you have to figure out why it failed. If it doesn't necessarily match, there's always a chance that it partially passes too. So having a notion of what that is very helpful. Last but not least, again, because this could be more than just these pieces, what does it cross-reference? So a test case should match a requirement, or it should match a UML artifact. You should have traceability between your tests to all of your requirements, basically making sure that everything in your system is being checked and validated. If you have a requirement that doesn't have a test case, how do you know if it's being performed or not? All right. I've got an example here in the slides. I updated the slides this morning, so if you want a visual, I've got that there. Anyway, we have hit 150, so I will see you all on Monday. Again, we'll do an in-class lab if you missed the initial part of class, and I will see you all then. Have a wonderful weekend. And yeah, don't forget to get your homework done. Bye, everybody. You as well. Thank you. Hey, it's time for the weekend. We need a few dancing crabs. There we go. That's better. All right. Have a good one.